Let's go over graphing quadratic functions by using vertex form and transformations. So the vertex form is of this form, which you have to memorize. It's a times x minus h squared plus k. And a good way to memorize it would be that you're basically taking ax squared plus bx plus c and trying to complete the square. If you complete the square, you get this much with a, and there should be some other remaining number here. Now the reason that you have a minus here is because if you do it this way, then h comma k would be the vertex. But let's go over some other properties. So first, if a is positive, then the graph opens up. So you know that the quadratic equation has the graph as a parabola, and the graph opens up in this direction, okay? And if a is negative, then it's upside down, like a frown, okay? Or the graph opens down. And as I said, the vertex of the parabola is h comma k, and that's why this is called the vertex form. And a good way to find out the value of h from a quadratic equation that's given like this, because often you're not going to be given the vertex form, but you will be given this, and you will be asked to change this into the vertex form. If you need to do that, you just have to remember to use this formula, h equals to negative b over 2a. Very important. You should memorize this as well as this one. A way to help you remembering this would be that this is part of the quadratic formula, right? X equals to negative b plus minus square root of b squared minus 4ac over 2a. If you take that quadratic formula and delete the square root as well as the plus or minus, then this is what you get. And the reason that this is the x-coordinate of the vertex is because that if you have a quadratic graph, so if you have a quadratic graph and there are two roots, two zeros, sometimes people call it, then the midpoint is the same coordinate as the vertex, right? So the midpoint of the two roots is actually the x-coordinate of the vertex. And if you have plus or minus, that's like saying that there's this point, negative b over 2a, and there's plus or minus of this strange quantity square root of something. So that's why this part only gives you the midpoint, which is same as the x-coordinate of the vertex. Okay, so that was a really quick explanation why it is so. But you can also figure this out by using completing the squares and some other ways. Alright, so let's go back. How about k? Well, you get the k value by plugging in the value that you found for the x value, because if you have a point on the graph and you know its x value, to get the y value, you just plug in that value. Okay. Alright, now I should try to explain these two using some examples. So let's just do two examples and you should be able to understand what this is about. Okay, first, you have 2x squared plus 4x minus 3. And remember, you have the formula h equals to negative b over 2a. Very important. And in our case, this is the value of b, and this is the value of a. So we need to do negative 4 over 2 times 2. So it's equal to negative 1. Now to get the k, you have to plug that value in. So to every x, you put parentheses, and then you write in this number that you're trying to plug in. And that's important because things like this, if you don't have the parentheses, you'll be very confused in whether you get a positive 1 or negative 1. Okay, but this would be positive 1 times 2, so that's equal to 2. Negative 1 times 4 would be negative 4, and then minus 3, so it's going to be negative 5. So we know that -1, -5 is the vertex. And there's actually another thing that you should know, that this C, this is same as the y-intercept. And that's very handy in graphing it, because if you plug in 0 into x, you get the y-intercept, and you only get -3, right? So it's always that if you have ax squared plus bx plus c, c is always the y-intercept. Okay, so actually you can already draw the graph. So you can already draw the graph, because here is -1, -5. Here's -1, -5. And -3 is right here. That's your y-intercept. And you can draw the graph as -1, -5 is this point. That's your vertex. And because it has to pass through this point, it better be going like that. And that means because the parabola, or the graph of the quadratic equation, is symmetric with respect to its vertex, or the axis of symmetry, it should go up like that, so that this is indeed the vertex. So that's the graph. Okay? And the vertex form itself would be y equals to a, which is 2, x minus -1, because h is -1. Remember, the formula is ax minus h squared plus k, right? And then plus -5, because k is -5. And you want to simplify just the signs, but leave it otherwise. So it's 2 times x plus 1 squared minus 5. That's the vertex form. You don't want to expand this, because then it's going to go back to this one, which is called the standard form. But it's asking for this vertex form. So this is the vertex form. This is the graph, and you're done. Now, a little bit more explanation of what this has to do with transformations is, if you start with y equals to x squared, let me use a different colored pen. Suppose you start with, say, y equals to 2x squared. It's a parabola, and bigger numbers means it's thinner. You have a thin parabola. And if you do y equals to 2x plus 1 squared, the graph moves one step to the left. And then finally, if you subtract 2x plus 1 squared minus 5, then the entire graph goes down by 5. So that's why you get this graph, where this point is -1, -5. Alright? Now let's look at the second example. Convert y equals to -3x squared plus 9x minus 3 into vertex form and draw the graph. This time, again, h is equal to -b over 2a. h equals to -b over 2a. And this would be negative. b is 9. a is -3. You have to include the negative sign. If you have a number and there's a negative sign, you have to include the negative sign for this formula, okay? Always include the negative sign. Then negative times negative divided by negative will be gone, and you have 9 divided by 6. But because these are both divisible by 3, you have to divide by 3, and that gives you 3 over 2. So 3 over 2 is your h. To get the k value, you have to plug in 3 over 2 into this function. Let's do this carefully. Plugging in means anytime you see an x, you replace it by parenthesis. Replace it by parenthesis. And then you write in 3 over 2 into the parentheses that you have. Okay, so I should have said like this. So it's like this. You have k equals to this. And as you can see, this is exactly the above equation with x vacated and replaced by parentheses. And into that parenthesis, what we are trying to do is to plug in the value of h. 3 over 2 is plugged in. Okay. All right. If we do that, what is it? First, if you square a fraction, both top and bottom are squared. So 3 squared is 9. 2 squared is 4. Plus, if you multiply a number to a fraction, it only gets multiplied to the top. So 9 times 3 is 27 over 2 minus 3. And then this is 3 times 9, again, negative 27 over 4. But because you're trying to make a single number, you better have common denominators. So for this one, I will multiply 2 top and bottom, because 2 times 2 will be 4, same exact denominator as the first one. And 3, think of this as 3 over 1. Again, multiply 4 top and bottom, so that the denominator will be 4. And that gives you negative 27. Twice of 27 is 54. And then minus 12 over 4. And that's this will be positive 27. Positive 27 minus 12 would be 15 over 4. Okay, so we got the vertex as 3 over 2, comma 15 over 4. And the vertex form of the equation as y equals to negative a x minus 3 over 2 squared plus 15 over 4. Okay, now for the graph. What do you do for the graph? Well, first you plot the vertex, so 3 over 2, let's say 3 over 2 is here. 15 divided by 4 is like 3 point something, so let's just say this is 15 over 4. Let's say this point. And then this negative 3, that's your y-intercept. I explained this in the previous example. So you have negative 3 as, actually, since this is like a little bit bigger than 3, let's call this as negative 3. Okay, so we know that the vertex should be here and the y-intercept is here. Let's draw a graph that's passing through both. So comes down. And then because this is the vertex is like the turning point of the quadratic equation, so it will turn back. So that's the graph that you're going to get.